Welcome to the Arithmetic Zone and welcome back to our Simple Java series. Today we're going to look at iteration, which is the repetition of code. As you can see right here, I have 5 print statements lined up right here. They all accomplish the same thing where they print the word hello to our console. So if I run our code, you see 5 hellos printed out as such. And if I want 10, I could just copy and paste this. And so now I have twice as many, and now it prints 10 hellos. While as of now, this is easily manageable. You can tell that if I just keep increasing the amount of hellos, like let's say I want to print this 100 times, it's going to be, difficult to, just keep copy and pasting over and over. And it's also going to be difficult to debug. Like let's say, oh, I missed one hello, and I don't notice that it actually prints out 99 times. So how can we prevent this issue when we just want to repeat the same code? Well, there's multiple ways. The first way is through a while loop, which I'll show you right now. The while loop format, you just write the word while, and then have parentheses, which is going to be our condition, and then brackets. So visually, it's very much like an if statement. And just like an if statement, what goes into parentheses is the condition in order for this code to work. So let's say in the while loop, we're going to have a variable. So we're going to make a variable before the while part. So let's say int count is equal to 0. So we have a count variable, we're setting it to 0, and we're going to say while count is less than 10, and inside of here we're going to have our system.out.println hello statement. So it's pretty easy to see what I'm trying to do. I'm trying to use a count variable, and by using this while statement, I'm trying to say that while the count variable is less than 10, so every time it's less than 10, it's going to print out hello. But we're not actually changing the count variable yet. So after printing out hello each time, we're going to have to increase count by 1. Now if I were to print out this code, it should print out 10 hellos, but let's make sure. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So successfully prints out 10. And let's go through this code one line at a time so we see how this works. So I initialize count to 0. Okay. Now I'm saying while count is less than 10. Okay, well, count is currently 0, so 0 is less than 10. That's true, so it's going to run this code. So it's going to print out hello. Now count's going to increase, so now count is 1. And because this is a while loop, it's going to go back to here. It's going to check the condition again. 1 is less than 10. It's going to run it again. Count's going to increase to 2, and so on and so forth. By the time we get to 9, so once count is 9, 9 is still less than 10, so it's going to print out hello. Count's going to increase to 10. It's going to go back here. Now when it checks if count is less than 10, well, now that count is 10. 10 is not less than 10. It's equal. So because the condition in the while loop has finally been false, it's not going to run that time. So hence this while loop runs when count is from 0 to 9, which if you count 0 to 9 individually, that is 10 numbers, hence it prints out 10 hellos. So that can be difficult to understand, and that's why there's another kind of loop that you can use, and for purely numerical situations like this, I think it's superior, and it's called the for loop. So let's rewrite this code segment, but let's do it using a for loop. So what I'm going to first do is write the word for, and then again parentheses and again brackets. So again, similar to the while and if loop structure, but inside the parentheses is going to be a lot of stuff. So let's keep it in mind. The first thing we need in a for loop is to initialize a variable, which might sound weird. Usually you initialize variables outside of these, condition parentheses, but for a for loop you do it inside. So we're going to say int I is equal to 0, and I is generally standard. I'm pretty sure stands for iteration, and I is like the most common letter used for these for loops increments, so we're going to use I. So we made I equal 0, which basically the equivalent of making count equal 0 right here before the while loop. Now I put a semicolon because we need to separate the initialization with the next part, which is going to be the condition. So the condition is while the count variable is less than 10. So I is less than 10. Again, this segment is the same as right here, just like how this segment's the same as this right here for the while loop. But that's not all. We're also going to need the increment. So we want to increase I by 1 every time, just like right here, count plus plus. So I have these three parts. I have my initialization, I have my condition, and I have my increment. And then after all that, we're going to write system.out.print ln hello, and make sure you spell it correctly. Alright, and if I were to run this code, prints out 10 hellos, but we got to make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Prints it out 10 times. So we know that this for loop works identically to this while loop. And look how much, less lines I used. I saved a lot of space, and I think this one's also just easier to understand, especially, once you work with like different numbers. So let's do that right now. Let's say instead of changing I by 1, let's change it by 2. How can we do that? Well, when you want to increment something by 1, you could just use the shorthand plus plus, the unary increment. But if we're doing if we're adding by like any other number, then we're gonna have to write plus equals and then the number we increment by. So plus equals 2. How is this gonna change your code? Let's see. Prints out hello, but now it only prints it out 5 times. But why is that? Alright, well, I 0 is less than 10, it's gonna print out hello. Then it's gonna increase I by 2. 2 is less than 10, it's gonna print out hello. Then increase I by 2 again, so now I is 4. So yeah, now that I is increasing by 2, it's gonna reach 10 twice as fast. Hence, it only prints out hello 5 times instead of 10. And we can also go backwards right here, but be careful. If you're going backwards, make sure your condition makes sense. You wouldn't want to use less than a number. You probably want to use greater than a number. So instead of printing out, a word, let's print out the value of I, which we can actually reference right here. So when we do that, now we print out the increment number. So now we can actually see how I is changing for every iteration. Let's make this a decrementing loop. So let's start from the number 10 and have it decrease by 2. And again, we're going to have to change this condition. So instead of making it so that I is less than 10, I is equal to 10. So by default, this should just not work at all if I were to run the code. Yeah, nothing gets printed because first time it checks it, it's false. So we got to change this condition. Let's say I is greater than or equal to 0. So now, because it starts from 10 and decreases by 2, right, it's going to start from 10, then 8, 6, 4, 2, and then it's also going to print out a 0 because it's checking if it's greater than or equal to 0. If I remove the equal to, it shouldn't print out the 0, right, because once it's 2, it decreases by 2 to 0, and then 0 is not greater than 0, hence it's false. So for loops are definitely, easier to manage when you're, working with just, simple iterations like this. You might be wondering what the purpose of while loops is. Well, while loops are technically more powerful because with for loops, you're limited to these bounds right here. But with while loops, you can put pretty much anything in this condition. You can make while loops with user input. So let me demonstrate that real quick. Of course, user input can be annoying to do in Java. So here I made a basic algorithm where I replaced the count variable with a new num variable that's determined using user input by using the scanner class. So what this should do is that when you run the code, when you enter a number, the code is going to tell you back you entered this number, and it's not going to stop doing that until you enter -1. So let's run the code. Alright, we don't see anything yet because we got to enter a number. So let's enter the number 1. You entered 1. Let's enter the number 2. Alright, 3, 2 again, 4. Now if I enter -1, the code stops running, and that's because if we look at our code, it says while num is not equal to -1, it's going to keep running. As soon as you enter a number that is -1, it's going to stop running. So while loops are definitely more flexible for these sort of situations. And also, any for loop you write, you can turn into a while loop. So I had this little for loop where it started from 10, decreased I by 2 until I is greater than 0. I can easily replicate that. With a while loop. So we can just say while count is greater than 0, and then have int count is equal to 10. System, system.out.println count, which is basically I, and then count minus equals 2. And you see it twice because both of these function the exact same. So depending on your situation, a while loop can be better because it's more flexible, or a for loop can be better because it's more simplified. So here's a neat little algorithm I wanted to show you guys. What this does is it prints out the digits of a number starting from the ones digit. So we have the number 783 as an example, and using a while loop, we're going to take the digit, we're going to take an individual digit, which is just a single digit number, starting from the ones place by using mod 10, which I went over. And then we're going to print out that digit. And then after we do that, we're going to divide the integer number 783 by 10. And because it's an integer, it's going to just get rid of the decimal portion. So it's going to become 78 and then 7 and then 0. So let's see this in action. Prints out 3 first, and then 8, and then 7. After all, the only thing that's getting printed is the digit portion. Now, please be careful. Whenever you use a while loop, always make sure that whatever, condition you're testing, make sure that variable can actually, change, and make sure it's actually possible for you to end the loop. Because let's say I didn't have, divided by an equals 10. Let's say I didn't have that. So we're just going to end up printing out the digit, and then the number is not going to decrease, or rather it's not going to get divided by 10. So we're never actually going to get to the next iteration. So what do you guys think is going to happen? It's going to keep running the code forever. And you want to stop code by pressing Control C. So Control C to stop the code in the terminal in Visual Studio Code. Remember that. And yeah, it's dangerous to have infinite loops because, if you have a program that just keeps running on forever, you can crash your program and some bad things can happen. So make sure whatever condition you're testing in a while loop, it's actually subject to end. In a for loop, that issue is a lot less common because you're pretty much encouraged, just by having that for loop header to avoid the infinite loop. But it can still happen with a for loop, so be careful. On the topic of for loops, let's look at a for loop that uses strings instead of numbers. So we make this string word, which is set to Java, and then now we have this funky looking for loop with some funky looking code. So this part looks familiar. For int I equals 0. Okay. Then our condition, I is less than word.length. Alright, well then I++, that's familiar. And instead of printing out, a number, we're going to be printing out an individual letter by using word.substring. And inside of the two parameters, we're going to be using I to refer to the current letter and I+1 to refer to the next letter that doesn't actually get printed out. So essentially, because I is 0, it's going to print out substring 01, which is right here. Then this letter, A, and then V, then A. It's going to keep going until, it reaches the word length, hence why that's our condition. So we run our code. It's going to print out each individual letter on a separate line because we used println and not just print. If we did use print, though, it should just print out the word as is, just like that. So that's the basic example of string loops. String loops can get very complicated very quickly. I'm going to show you a more complicated example right now, but it's still relatively easy to understand. So here we have another string algorithm using a for loop. And much like the last one, it functions the same, where it takes a word and it iterates through the letters by using word.length as the condition. The word in question is Mississippi, but obviously after the for loop header, this if part, looks a little complicated. So I think it's best to understand this code after printing it out. Prints out 4 S's. So what's happening right here? So we're iterating through every letter in Mississippi by using I and word.substring, but we're not actually printing out every letter, because for every iteration it's checking if the current letter by using word.substring I and I plus 1 if it equals the letter S. And remember, if you're comparing strings, you have to use dot equals. You can't just use the Boolean operator like the double equal signs. That's like for numbers. So if and only if the current letter equals S, we're going to print out that current letter. And if we look at Mississippi, there are 4 S's together. So hence it prints out 4 S's, each on its own line. If I change the code so that instead of printing out S's, or instead of comparing each current letter to S, instead to P, it should print out 2 P's, because there are 2 P's in Mississippi. So as you can see, the string algorithms using iteration can get very, very complicated. This condition is quite long. I mean, look how much space that takes, and it's only going to get worse from here. This is pretty much a basic example. And after all, this is basically simple Java. So to conclude this video, I'm going to go over one more concept, which is nested loops. So I just made a nested loop, and before I continue, just to show you off, if you ever want to clear your terminal on Visual Studio Code, you just go here and just press Ctrl L. So just so you know that. Anyway, I made a nested loop, which, as you can see, it's basically when you just put a loop inside of another loop. It's not 2 loops after another, it's specifically when it's inside. Notice how it's inside the blue brackets, it's not outside of it. So when you have a loop inside of a loop, that loop that's inside is going to run for every loop from the outside. So you're going to have a lot of loops basically. So if you look right here, I'm incrementing from 0 to up to but not including 5 for both of these loops, and I'm printing out the letter I in the inner loop. So let's see what it does if I run it. So prints out what appears to be 5 zeros, then 5 ones, 5 twos, 5 threes, and 5 fours. And the reason why it does that is because, well, let's look at this. So this outer loop is going to run 5 times, but this inner loop is actually going to run 25 times, because it's going to run 5 times every time this outer loop runs. And because the outer loop runs 5 times, this is going to run 25 times. And it's going to print out what the value of I is, which doesn't change after this runs 5 times. Hence, it's going to print out 5 of the same number, and then it's going to change like that. Now, the thing with these nested loops is that they can get very complicated when inside of these, inside of the for loop header, you actually reference what the original increment value is. So let's say instead of starting from 0 for the inner loop, let's start from j equals I. And now if we run it, well, we get a very different result. First part is the same. It's going to run 0 5 times, but then it's going to run 1 4 times, 2 3 times, 3 2 times, and 4 only once. So why is that happening? Well, when I is 0, nothing's changing because, well, if you remember, it started off as int j equals 0. And because if I is equal to 0, it's going to run the same. But when I is a number greater than 0, it's going to start from that value and it's going to increase up to 5 from that point. So it's actually not going to run as many times because it's starting from a greater number. So by the time we get to 4, so if I is equal to 4, that means j is equal to 4 when it's initialized. So this is only going to run once because, once it runs, j is going to be 5, and then 5 is now less than 5. hence why that happens. And I can demonstrate this if I also run if I also print the value of j along with I for every iteration. So we have I on the left side and j on the right side. So we see how j is always gonna change like that. It's always just gonna be 0 1 2 3 4, 1 2 3 4. It's always gonna change, while I isn't gonna change until the inner loop is done with its thing. So nested loops definitely pretty complicated, especially when you're doing nested while loops, which are pretty rare. You don't really see those often, and I'm not really gonna go over them, but I think you guys get the point. If you struggle to understand a lot of these algorithms, that's okay, because a lot of these algorithms, it's best to understand by just running them multiple times, or even just taking a piece of paper and just taking notes for every single iteration. Iteration is definitely like a big difficulty spike when learning any coding language. Even selections and conditionals aren't too bad because everything's just running once, but once you get iteration involved, it can definitely be a hassle. Anyway, that's going to be it for this video, and I'll see you guys next time.